हरिः कर्ता।
Now let's figure out the ordinal variables from our work from our real world data sets. So, but before we do that, I just want to explain. I just want to give some examples of ordinal data uh, in comparison with the nominal data, because see, nominal data, ordinal data look similar, but they are not same. That is the reason I just want to give you the examples in comparison with one another. So there are, as we have discussed earlier, there are four main data types or levels of measurement. So nominal, ordinal, interval, and ratio. So out of that, nominal data is qualitative data used to name or label variables without providing numeric values. It is the most straightforward form of a level of measurement. One, done. Next, ordinal data is also qualitative data that groups variables into ordered categories. That's where the difference lies. It groups variables into ordered categories. The categories have a natural order or a rank based on some hierarchical scale, like from high to low, 1 to 5, 1 to 10, like that. So, while nominal data is classified without any intrinsic ordering or rank, ordinal data has some predetermined or natural order. I think it's clear for you. So now, what are nominal data statistics and what are ordinal data statistics? In statistics, nominal data is qualitative data that groups variables into categories that do not overlap with each other. Nominal data is the simplest measure level and are considered the foundation of statistical analysis and all other mathematical sciences. So they are individual pieces of information recorded and used for analysis. So nominal data cannot be ordered and cannot be measured, whereas ordinal data can be used with some mathematical calculations. So now let's look into some of the nominal and ordinal data example. First example of nominal data. Which state do you live in? Followed by a drop down list of names of states such as Andhra Pradesh, Karnataka, Tamil Nadu, Madhya Pradesh, Uttar Pradesh, Gujarat, and many more. And second example of ordinal data. Rate education level according to, example, education level, education hierarchy, elementary, high school, college, graduate, postgraduate, and PhD. I hope you got it now. Both are categories. One does not have order, other has order. So example of ordinal data, educational hierarchy in India: elementary, high school, college, graduate, postgraduate, post PhD. Okay. So now few more examples of ordinal data. I hope you got the difference. So few more examples we'll take. An ordinal data. An organization asks, let me put it in the sheet, both. This is for its ordinal data. So example of ordinal data. Let's take an organization asks employees to rate how happy they are with their manager and peers according to the certain scale. The scale is scale the scale of happiness. Yeah, scale of happiness. If you are extremely happy, then scale it as 1. And if you are just happy, scale it as 2. If you are neutral, then scale it as 3. If you are unhappy, and 4. And if you are extremely unhappy, then scale it as 5. So this is the best example of an ordinal data. So by inherently they have that order: extremely happy, happy, neutral, unhappy, extremely unhappy. So this is called an ordinal data. So now let's look into an example of nominal data, just to have that clear cut differentiation, to keep that clear cut differentiation in your mind. So I'm giving one more example of nominal data. So example of nominal data. So one, which is the most loved breed of dog? So one question, that's which is the most loved breed of dog. So first option, you will have a Doberman 1. Second option, Dalmatian. And third option, Labrador. And fourth option, German Shepherd. So this is the best example. It doesn't have any order. You can vote it to anything. There is no inherent order to any of the categories in nominal data. That's the main difference. And for example, if you want to take one more example for the uh, nominal data, we can take it second example as a real estate agent surveys to understand the answer to the following question. The question is, which kind of houses are preferred by the residents of Bengaluru, Namma Bengaluru. Okay, so first one is apartments. That's an option A. You can represent as A, but it does not have any order. Then bungalows, you represent as B. Then villas, then let's see. Okay, these are all called nominal data, and this is the difference between nominal data and ordinal data. Now let's take some some data from the Amazon reviews data. Let's get into that and see how. So Amazon reviews is equals to pd.read csv Amazon e-commerce sample. So okay, it have mixed types, specified D type option on import or set low memory false. The issues with the memory. Let me set the one more argument. Okay, let me call it now Amazon reviews, and this is what is our data. Of course, it's a huge amount of data, so it's gonna take some time to store all. So what I'm gonna do, okay, there are a lot of unnamed variables. However, let's leave it like that. Okay, let me check the Amazon columns. Okay, forgot about this one. Of course, so you got index, unique ID, and then product name. Product name is which type of data it is. Product name is your nominal variable. A manufacturer, and then a price. Price is continuous variable. The number available in stock, its number, obviously it's which data it is discrete, a numeric and discrete. Number of reviews, again a discrete. Number of answered question, again a discrete. Average review rating, this is what I want. Let me copy this. And Amazon category and subcategory. So Amazon category and subcategories is all obviously your nominal variable. So let me take Amazon revs, and yeah, this is what is our reviews total. Oh, this is huge, huge data. It's huge data. So now Amazon reviews, so they got for the total out of 5 stars. You can take either from 1.0 till 5, 1.1, 1.2, 4.2, 4.3 such, and then so each has a definite ordinal. When you say 5 out of 5, it means you are very much satisfied with the Amazon services, Amazon products, for whatever for whatever feature you're voting, you're reviewing it. Of course, this is average review rating, so we can take it as you're satisfied with the Amazon all services. When I say 4.5, I'm not much as satisfied as 5. That means if I say 1.0, if I give 1.5 out of 5 stars, that means I'm not at all satisfied. If I give 0, I'm absolutely not at all satisfied. So there is an order. There is an order from one from 0. If you take from 1 star, then from 1 till 5, there is a clear cut order in the number, in the numeral. So that is the reason we call this as a ordinal. We call this as a ordinal data. Okay, 4.9, 4.5, totally you will have a 5 stars on an average they'll take, and you'll get, see, that's what you can do, the summary, you can do the statistical analysis on ordinal data to some extent. So that's what you see. They have taken this average of reviews that were voted. Normally you will have an option to vote 1 star, 2 star, 3 star, 4 star, 5 stars for different services of Amazon. So after that, they have done this average, and this is what you got. And each has a specific meaning. 4.9 means the highest satisfaction. 1.1 means a lowest satisfaction. This is what an ordinal and ordinal data. And similarly, if you look here, you got the customer ID. This is unique, and after that you have a gender. We will see this type of data in our next slide. Then you have age. Age is absolutely discrete here. So here we are not mentioning 19.5 2 3 like that. It would be clear how many years, so it's discrete. Then you have annual income. Annual income in dollars, again, can be discrete. It's discrete or continuous, depends upon our requirement. Then you got the score. So this one I'm gonna take. You got the score here. Let me take the score. Second example. So CS dot columns. Okay, first let us see the data. So this is the data. This is customer segmentation data. So we got the customer ID, and then customer gender, age, and annual income. So obviously these are the attributes of this customer ID, whatever column that you see. Okay, so this respective customer ID. So now if you see, there is a spending score of the customer. So what is this? Now let's take this one. So CS dot columns. So I want this spending score. Spending score is between 1 to 100. Let me copy this, and CS of and execute. Oh, sorry. Yep. So this is what I'm gonna go for the unique. So unique. These are the unique value. So it's int 64 that you can see. So when that customer gets a score of 81, that means done he has done very well. Whereas the guy who gets 4, he has done very worse. That's what there is a clear cut order from 4 from 1 to 100, from 1 to 100 in the score, in the spending score. That's why it's called as a ordinal data. If it is 54, it is average. If it is 89, it's above average. If it is 90, it's excellent. It's clearly telling you something about that customer, how is doing. So that's why this data carries some order with the values. So that is the reason we can do some statistical analysis also. So this is another example. If you see that, and here this is our ordinal variable, ordinal data. On other side, you have a profession. This is a nominal because you have certain amount of profession, certain amount of labels for that. Let me take the profession just to prove it, just to show you both ordinal as well as nominal at the same place. Let me check profession here. So CS of, yeah, let me go for the unique. So engineer, lawyer, entertainment, healthcare. So these are all unique. Okay. So these are all nominal variables which specifically do not have any order or any weightage they carry with them. So that is the reason these are all nominal data. This is nominal data. So here you can see that this is ordinal and this is nominal. And after that you have work experience anyway. You can say in 1.2, 1.3, but you will never say 1.3245. No, that's why this is also discrete. And when it comes to the family size, it's clear cut discrete, because you will not say 1.5. We are a family of 1.5. We are a family of 4.4. We say we are a family of 4, 5, 6, 7. So that's why these are discrete. So now here you can see all types of variables by and large. So now let me take one more example. Uh, Let me look into the data. So this is Amazon e-commerce, soccer stores, and customer segmentation data. Yep. Okay. So stores, soccer, e-commerce, and customer segmentation data. Yeah, we have seen both the examples here. You can see that. Okay. So that's the difference between an ordinal and the nominal variables. Now we will be looking into uh, dichotomous or binary data.